In section 6.5, we're going to be solving equations that have radicals in them. So the first thing that you're going to want to do is isolate the radical. That means that you're going to want to get the radical on one side of the equation by itself, preferably with no coefficient in front of it, but I will also show you how to deal with it if you can't get rid of that coefficient. If there happen to be two radicals in your equation, my best advice is to get the more complicated radical by itself on one side and put the one that's more simple on the other side. We'll see an example of that a little bit later on as well. So step 2 is going to be to raise both sides of the equation to the power of the index. So here's what I mean by that. If we were to have, say, the cube root of x plus 2 equals 3, then what we do is we see that the index is a 3. So what we're going to do is raise both sides to the third power. And what ends up happening is when we take a cube root and we cube it, then that undoes the operation because they're inverse operations. So cube root of x plus 2 cubed leaves us with x plus 2. And then we're going to do 3 cubed on this side. So 3 times 3 times 3 then would be 27. Similarly, if we had the square root of x plus 2 equals 3, then what we would do is identify the index. The index here is a 2 because it's a square root and we don't write the index of 2. So we will square both sides and we would get x plus 2 equals 9. Now there is a caution. If you would happen to end up with a variable on the side that doesn't have the radical, so if I would have had x plus 3 instead of just 3 here, and I wanted to square it, then that means that I would need to do x plus 3 times x plus 3 and FOIL. So be careful if you have a variable, a binomial with a variable in it, you need to FOIL that, not just make it into x squared plus 4. Okay, the third step is to solve the resulting equation. So in this case, I would subtract 2 to both sides and I would get x equals 25. And similarly, subtract 2 from both sides and I would get x equals 7. There's really two types of resulting equations that you might see, basically. One is linear, that's like these up here, meaning that there is no x squared term. So if you have a linear equation, what you're going to do is move the variables to one side and the constants to the other. So just like I said, subtract 2, and I get my answer. The other type of equation we might end up with is quadratic. And quadratic has an x squared in it. So if you end up with something like, that has all 3 terms in it, ax squared plus bx plus c, then we know a couple of ways to solve that. One way that we could solve is to factor. Another way we could solve is the quadratic formula. If you end up with a quadratic that doesn't have an x term in it, so just like ax squared, no bx term, but then just plus a constant, then we can use the square root method. Or you could still use the quadratic formula. So the quadratic formula will work for any quadratic equation, which is kind of nice if you are good at using it. Then the next step only happens some of the time. But actually what you're going to see is most of our problems are going to be square roots, so we're going to have to do it most of the time anyway. If you had raised both sides to an even exponent, then you must check for extraneous or false solutions by substituting all answers into the original equation. Then what we're going to do after we substitute back in is you work out both sides of the equation separately using the order of operations. And if they end up matching, then your solution works. If they don't match, it's an extraneous solution. Okay, let's look at a couple of examples. Excuse me. Okay, we'll do this one first. 9 plus the square root of 1 minus 35m equals 15. So remember, step 1 is isolate the radical. So I'm going to start by subtracting this 9 from both sides, which leaves me with square root of 1 minus 35m equals 6. The next thing I'll do is raise both sides to the power of the index. So this is a square root, so I will be squaring both sides. Remember that when I square a square root, that radical goes away. So I have 1 minus 35m equals 6 squared is 36. I then subtract the 1 from both sides because I have a linear equation. I get negative 35m equals 35. Divide both sides by negative 35. And I get m equals negative 1. Now, I have to ask myself, do I need to check my answer? And I need to check my answer if I raised both sides to an even exponent. Since I squared both sides, I do need to check. So I will check by taking my original equation and substituting in negative 1 for m. So I'll do 9 plus the square root of 1 minus 35, parenthesis negative 1, because I'm just replacing that letter m with a parenthesis negative 1, equals 15. Now I'm not going to do anything other than carry this 15 straight down because my steps are to simplify the left-hand side and the right-hand side separately. So I'm just going to follow order of operations on this left-hand side. The square root kind of acts like a parenthesis almost. So it's grouping this stuff together. So we'll do what's inside the square root first, kind of like quadratic formula. So we have 1, and then negative 35 times negative 1 makes plus 35. So then we have 9 plus the square root of 36, which makes 9 plus 6, which actually does equal 15. So m equals negative 1 is a valid solution. This example here, 5 square roots of x plus 7 equals 8. We are going to start the same way. So we will want to get the radical by itself. So subtract 7, which gives us 5 square roots of x equals 1. Now, normally I would tell you to divide both sides by 5. If I divide both sides by 5, though, I'm going to end up with 1/5, and then that's a fraction, and people don't like that. So I have a note over here. When there is a number in front of the radical, like this, if you cannot divide both sides by that number, then what you can do is square the number. So we will square the number and replace the radical symbol with parentheses. So, for example, if I had 3 square roots of x plus 2 and I wanted to square both sides, then what I'm going to do is square the 3, which makes it a 9. And instead of a radical, I put a parenthesis with x plus 2. which makes this 9x plus 18. So since I'd rather not deal with a fraction up here by dividing both sides by 5, I'll go ahead and leave the 5 there, and I'm just going to square both sides. So here on the left side, I'm going to square the number, replace the radical with parentheses. So 5 squared, 25, replace the radical with parentheses. On the right side, I'll do 1 squared, which is still 1. So I have 25x equals 1. I will divide both sides by 25. That still leaves me a fraction, but it's an easier way of getting it. So it's 1 divided by 25 is 1/25. Now, do I have to check my answer? Yes. How do I know I have to check? It's when I raise to an even power. So if I raise to an even power, I have to check. So then I'm going to take 5, and instead of square root of x, it's going to be square root of 1/25 plus 7 equals 8. So this right-hand side just keeps going along. And I've got to do all the work on the left-hand side. So remember, when we see the square root of a fraction, we can think of it like 2 separate square roots. And I know the square root of 1 is 1, and the square root of 25 is 5. So now I have 5 times 1/5 plus 7. 5 times 1/5 is the same thing as 5 over 1 times 1 over 5. We multiply straight across with a fraction. So that is 5 over 5 plus 7. And since 5 over 5 is 1, that's 1 plus 7 equals 8, which is true. So x equals 1 over 25 is a valid solution. I'm going to start doing some problems on notebook paper, and that's basically going to be 6.5b is going to be the problems that I'm working on next. So if you want to stop your video now, you sure can, but 6.5b is what I'm going to be covering at this point. And it's just some more examples. There's no new notes. There is new information, but no more handout or anything like that. Okay, so this is my first problem that I'm going to do for 6.5b. 45 minus 9x raised to the 1/2 power equals x minus 5. Now, remember that we've seen these fractional exponents before. Something to the 1/2 power, so if I have anything to the 1/2 power, so stuff to the 1/2 power, remember what that means, that fractional exponent. Remember, the numerator is the power that goes on the radicand. The denominator is the index that goes to the radicals. So this would be the same thing as the square root of stuff. So if you see a 1/2 power, no worries. You can just rewrite that problem as the square root of 45 minus 9x equals x minus 5. And now it looks familiar like what we've had before. So we're going to follow those same steps. Isolate the radical. That means get the radical by itself on one side, which we've already done. And then we're going to raise both sides to the power of the index, which is a 2. So raise that to the power of 2. On the left side, that gives me 45 minus 9x. And on the right-hand side, I am going to have to FOIL. X minus 5 times x minus 5, which will be x squared minus 5x plus 25. So that gives me x squared minus 10x plus 25. Now this is a quadratic equation. Quadratic. So we can solve this by factoring or using the quadratic formula. I'm going to start, either of those have to equal 0 before you can work through them. So I will add that 9x over to the right-hand side and subtract the 45 as well, so that I get 0 on the left-hand side, and that equals x squared minus x minus 20. Now the reason that I moved the 45 and the 9x to the right-hand side is because I want my x squared term to be positive when I factor. So then I can figure out what two numbers multiply to give me negative 20x squared, but add to give me negative x. If I take 4x and 5x, I know they need to be opposite signs because of the negative 20x squared, and I know the bigger number needs to be negative, so I get negative x here. So that will be plus 4x minus 5x. So I get 0 equals x squared plus 4x minus 5x minus 20. Group those. X times x plus 4. I need x plus 4 over here, which means I need to take out a negative 5. So 0 equals x plus 4 times x minus 5. Then by the zero factor property, I set, or the zero product property, I set x plus 4 equal to 0 and x minus 5 equal to 0. So I get x equals negative 4, x equals 5. Then I need to know, do I have to check my answers? Well, how do I know if I have to check? I look up here. Since I raised that to the even power, I have to check. So I'm actually going to have to check both of these answers. So if I check x equals negative 4, that means I'm going to substitute that back into the original equation. So I will do 45 minus 9 times negative 4 to the 1/2 equals negative 4 minus 5. I'm just going to work through the left-hand side first. So working inside the parentheses, that's 45 plus 36 to the 1/2, which is 81 to the 1/2. And that 1/2 power means square root of 81, which gives me 9. Then I'm going to work the right-hand side. Negative 4 minus 5 is negative 9. Since there's no other work to do, I'll just carry that down to the bottom. And I ended up with 9 equals negative 9. Well, guess what, folks? 9 does not equal negative 9. So that means x equals negative 4 is what we call extraneous, meaning it is a root that we found, but it's not a valid solution to the answer, or to the equation. So we cross it out, and then we're going to check x equals 5, kind of the same way. So we do 45 minus 9 times 5 to the 1/2 equals 5 minus 5. We work through the left side, so that would be 45 minus 45 to the 1/2, which would be square root of 0. And then on the right side, 5 minus 5 is 0. And the square root of 0 actually is equal to 0. So that checks out, meaning x equals 5 is a valid solution to the equation. Okay. Let's look at this one. Square root of 4x plus 5 minus square root of x minus 1 equals 3. So remember on the very beginning when I said if you have two radicals, you want to isolate the one that's more complicated and move the simpler one to the other side? So that's what I was talking about. So the square root of 4x plus 5 is a more complicated radical than x minus 1. So we're going to go ahead and move the x minus 1 to the other side. Oops, x minus 1. So now we have square root of 4x plus 5 equals 3 plus square root of x minus 1. And then we're going to go ahead and raise both sides to the power of the index. So I'm going to square both of the sides, square. Now on the left side, this square root and the squared cancel each other out, and I get 4x plus 5. On the right side, that is not the case. I am going to have 3 plus square root of x minus 1 times 3 plus square root of x minus 1, and I am going to have to FOIL. So to FOIL these, I take the first times the first, which gives me 9, and then the outside times the outside, so 3 times positive square root of x minus 1 becomes 3 square roots of x minus 1. Inside times inside, square root of x minus 1 times 3, so another plus 3 square roots of x minus 1. And then last times last, square root of x minus 1 times square root of x minus 1 is going to make regular x minus 1. Now I have to isolate the radical again. So I'm going to combine like terms. The 4x plus 5 I'll leave over here. And then I have 9 and negative 1 makes 8. And then I have 3 plus 3 makes 6 square roots of x minus 1. And then I still have plus x. I'm still working to isolate that radical. So I'll subtract x from both sides and subtract 8 from both sides. So now I have 3x minus 3 equals 6 square roots of x minus 1. Now here's another case where if I divide by that 6, I'm going to end up with fractions. So I will just square both sides as it is. On the left-hand side, I'm going to need to FOIL. 3x minus 3 times 3x minus 3. So that will be 9x squared minus 9x from the outsides minus another 9x from the insides makes minus 18x. And then negative 3 times negative 3, positive 9. And then remember, when we square with a number out front, I am going to square the number, so 36, change the radical into parentheses, x minus 1. Then I can distribute and get 36x minus 36. Now this is a quadratic equation, so I will move my 36x to the left side, move my 36 to the left side. So I get 9x squared minus 54x plus 45 equals 0. Okay, I am running out of room. You keep going down your page if you have room. I am going to move up to here. So now I'm going to factor. So I will start with a GCF because that's how we do. The GCF for these three terms will be 9. So I'll put 9 times x squared minus 6x plus 5 equals 0. Now I'm going to save you the time on factoring that, and I will just tell you it factors to x minus 5 times x minus 1 by the AC method. And then we're going to solve that. So remember, to solve, we're going to set each part that has a variable equal to 0. So I ignore the 9 because there is no variable. I set the x minus 5 equal to 0, so I get x equals 5. I set the x minus 1 equal to 0, so I get x equals 1. And those are the two solutions that I've come up with. Now, do I have to check my answer? Well, look back to the beginning. We raised both sides to an even power, and we actually did that twice. So I guess, yeah, we should probably check our answers. So I go to the original equation, and I'll check x equals 5. So square root of 4 times 5 plus 5 minus square root of 5 minus 1 equals 3. So that would be square root of 20 plus 5 minus square root of 4, which is square root of 25 minus square root of 4, or 5 minus 2 equals 3. Equals 3 equals 3. So that checks out. X equals 5 works. And then we'll check x equals 1. So square root of 4 times 1 plus 5 minus square root of 1 minus 1. So that would be square root of 4 plus 5 is 9 minus square root of 0, which would be 3 minus 0 equals 3. And that also works. So this one actually has two solutions. I have just a couple more that I want to go over with you. This one's kind of a weird looking one. The square root of x plus 9 equals the square root of x plus 3. So this is like inception of square roots. And the way that we're going to handle it is we will square both sides. So I'm going to start by squaring both sides. Now, when I square the right-hand side, I'm going to get x plus 3. When I square the left-hand side, this square can only take away one of the square roots. So I'm actually still going to have the square root of x plus 9 over here. I only got rid of one of the radicals. So what am I going to do now? I still have x plus 9 equals x plus 3. Well, I will just go ahead and square both sides again. So then that gives me on the left-hand side regular x plus 9. On the right-hand side, I will have to FOIL x plus 3 times x plus 3, which will give me x squared plus 6x plus 9 after I FOIL. And then I'm going to solve this quadratic equation. So I'll subtract over the x and subtract over the 9 so that I have a leading coefficient that's positive. So 0 equals x squared plus 5x. And that ends up being, plus 0, so I don't need to write it. And then I'll solve this by factoring. So when I start factoring, I always look for a GCF, and that is x. So I get 0 equals x times x plus 5. Since I don't have any more squared in there, I'm done factoring. So I will set each part that contains a variable equal to 0. So I go x equals 0 here, x plus 5 equals 0 here. And I'm going to get two answers, x equals 0, x equals negative 5. Do I need to check my answer? Yes, I need to check because I raised both sides to an even power. So I'm going to have to check that. So I'll do square root of 0 plus 9 equals square root of 0 plus 3. So this is square root of 9, which is square root of 9 is 3. So that's square root of 3. 0 plus 3 is 3. So square root of 3 equals square root of 3. That works. So x equals 0 is a valid solution. Let's try x equals negative 5. So I have square root of negative 5 plus 9, which would be square root of 4, which would be square root of 2. Let's see what the right-hand side does. That will be square root of negative 5 plus 3, which is square root of negative 2. And remember, when you have a negative inside a square root, that becomes an I outside. So I squared of 2 equals 2. That is not true. So x equals negative 5 is extraneous. And this problem only has one solution. Last one. 2 times the quantity x minus 3 raised to the power of 3/4 equals 54. So what I'm going to have you do in this problem is kind of similar to what we were doing before. We just didn't talk about it that way. Remember when we had a square root, say the square root of x plus 7 equals 12. Then our strategy was to raise both sides to the power of the index, which was 2. But when you think about square root of x plus 7, you could also write that as x plus 7 to the 1/2 equals 12. So when I have you raise both sides to the power of the index, another way to think about that is that I'm having you raise both sides to the reciprocal of that exponential power. So I'm raising both sides to the power of 2 over 1. So that's the same kind of idea that we're going to do here when we have this fractional exponent 3/4. First, I want to isolate the parenthesis to the fraction. So I'll do that by dividing both sides by 2. So then I have x minus 3 to the 3/4 equals 54 divided by 2 is 27. Then the next thing I'm going to do is raise both sides to the reciprocal of the exponent. So I will raise this side to the 4/3 and this side to the 4/3. Now remember, when you raise a power to a power, what you're doing is multiplying the exponents. So what I'm doing here is 3/4 times 4/3. So 3/4 times 4/3 is 12 over 12, which is 1. So now instead of x minus 3 to the 3/4 to the 4/3, it's really x minus 3 to the first power. And we don't normally write that if it's the first power, so we just write x minus 3. And then that equals 27 to the 4/3. So what I'm going to do next is I am going to write this in radical form. So writing that in radical form, I'll keep x minus 3 over here. The 27, which is the base, becomes the radicand. The index is the denominator of the exponent, so that's a 3. And then what we've done in the past is raise the whole thing to the numerator, which is a 4. Now we'll simplify this radical. So 27 is 9 times 3, which is 3 times 3 times 3. So x minus 3 equals cube root of 3 cubed to the 4th power. So this 3, this index of 3, means 3 have to be in our group to get out. There are 3 3s, so I have one group that gets out. So that will be x minus 3 equals 3 outside of the radical. No 3s are left in. And then to the 4th power, which gives me x minus 3 equals 3 to the 4th power is 81. Add the 3 to both sides, and that gives me x equals 84. Now, do I have to check this answer? Well, I did not raise both sides to an even power technically. You could check it if you want, but I will just go ahead and box it and call it good.